Kirkbride, and today we are looking at order of operations. So to begin with, vocab, order of operations, those are just simply the set of rules that mathematicians have agreed to use to evaluate expressions. Then that these rules are important is that mathematicians, just like people trying to communicate with one another, have to speak the same language. And if everybody just worked out problems the way they wanted to, they'd all come up with different answers. So we have to have a set way to come up with a value, and so we use order of operations. For our class, we're going to use the acronym PEMDAS, PEMDAS, to help us to remember the steps for order of operations. The P stands for, typically in the past we've only thought of it as standing for parentheses, but it actually stands for all grouping symbols. And those grouping symbols now, for the level of math that we are performing at, could be brackets, could be the division bar, I can't think of what these are called, but I call them wingdings. But anyway, it could be that particular grouping symbol. So any grouping symbol. The E stands for exponents. And exponents, remember, that tells you how many times to take your base to a certain power. So the exponent being the 2 there. I always put my M and D together. M and D is multiply or divide. Because they have the same level of importance, it's multiply or divide. It's whichever one you see first, reading left to right. And then of course we finish up with A and S, which is add, again, or subtract. They have the same level of importance. Add or, subtract. And again, that is left to right as well. So now that we've reviewed the order of operations, we're going to go ahead and try using the order of operations in a couple of examples. Guys, this looks like a crazy problem, but again, if we just follow order of operations, the problem itself is not incredibly difficult. So the first thing you want to look at is your P, your parentheses. Are there any grouping symbols in this problem? And as you look at it, you don't see any, so you're not going to need to work with those. The next thing we have are our exponents. Do we have any exponents in this problem? No. So here's where we're at. We need to either multiply or divide whatever we see first. Well, the first thing we see here is a multiplication problem. So I'm going to take this 50 times 2,000, which is going to give me 100,000. Now I'm just going to bring down my plus, and the next thing I see is a 7 times 64,100. Well, when I take 7 times 64,100, I end up with 448,700. Bring down my plus sign because I'm not using that. The next thing I see is another multiplication problem. So we're going to take 6 times 106,700, and that's going to give us 640,200. Again, I'm not ready for this plus, so I'm going to bring my plus sign down, and there is no operation occurring right here, so we're just going to copy that number down as well. Okay, so I've taken care of all of my multiplication. There was no division, so now we're ready for add or subtract. It means I can just simply, because these are all addition problems, I can just stack them all on top of each other, add, and I'll get a final answer of 1,387,800 using order of operations. So let's go ahead and look at a problem that's maybe a little closer to what you'll be dealing with. The problem here is 8 times the quantity 17 minus 2 3/10. And we want to use order of operations to solve this problem. Well, again, I want to first look to see, are there parentheses? Yes, there are parentheses. That means I have to do this math first. So I'm going to keep my 8. Remember that when you have a number right up next to a set of parentheses, that means you will be multiplying. And when I take 17 minus 2 3/10, I end up getting 14 7/10. So now I've done my parentheses. There are no exponents, so I need to move on to the multiplication problem that I have. And 8 times 14.7 is going to be 117.6. So my final answer is 117.6. Okay, let's look at another example. In this one, we have 14 plus 6 all over 12 minus 7. So using order of operations again, I'm looking for parentheses, but remember parentheses are not just parentheses. They are grouping symbols of any kind. This division bar is a grouping symbol. That means I have to do the stuff on top of it and the stuff on bottom of it first. It's forcing me to do that math. So that means I'm going to rewrite this problem as 14 plus 6, which is 20, keeping that division bar. 12 minus 7 is 5, so I end up with 20 over 5, which is a division problem. 20 divided by 5 is 4. Okay, one more example with numbers here. How about 5 times, and we'll throw in a bracket, 36 minus parentheses 13 plus 9, and my parentheses and my bracket. Okay, so order of operations. Again, first thing I want to look for, are there any grouping symbols? And as I look, I have 2 sets of grouping symbols. Well, you have to do the grouping symbols that are innermost first, and then you work your way out. That means I have to do this 13 plus 9 first. So I'm going to bring down my 5 because I haven't used it. I'm going to bring down my multiply symbol. I haven't used it. I still have this bracket here and this 36. Haven't done anything with those. Bring down my minus sign. Instead of 13 plus 9 in parentheses, we're going to go ahead and combine the 13 plus 9, and that's going to give us 22. Because I've done the math inside the parentheses, I'm going to drop the parentheses. I no longer need those, and then I'm going to end with a bracket. Okay? Again, I'm not finished with all of my grouping symbols. You'll see that I now have this bracket that I have to deal with. So I'm going to keep my 5, I'm going to keep my times, and now instead of writing what's in the brackets here, we're going to do the math. 36 minus 22, and that's going to give me 14. Because I combined this 36 and this 22, I no longer need these brackets, so I'm dropping them, and now I have just the 14. And now I take 5 times 14, and that's going to give me a final answer of 70. The point in doing what is in parentheses is so I can get rid of the parentheses. So once you've done the math inside the parentheses, drop your parentheses. Once you've done the math inside your brackets, drop the brackets. And then that leaves you to just finally simplify with your final operation. Quickly throw in some algebra so that we can evaluate some variable expressions. And the first problem we're going to look at is 4 times the quantity x plus y. And I'm going to go on to tell you that x is equal to 2 and y is equal to 5. So when they give you something like this, all you need to do, because they're telling you what x is and what y is, just go ahead and substitute in the 2 for x and the 5 for y. So rewrite your problem, keep your 4, keep your parentheses, but instead of x, you're going to substitute in a 2, keep your plus sign. Instead of y, you're going to substitute in a 5. And now you're just back to using order of operations. I have to do what's in parentheses first, so I'm going to keep my 4. Remember, anytime you have a number right up beside a set of parentheses, it's times. So 4 times whatever 2 plus 5 is, well, 2 plus 5 is 7. So 4 times 7 is 28. Your final answer on this particular problem would be 28. Let's look at another problem. 3 times the quantity x plus y squared. Again, we're going to use the x equals 2 and the y equals 5. So we're going to keep our 3. We're going to bring down our parentheses. Instead of x, we're putting 2. And plus, instead of y, we're putting 5. And we're going to keep that square out there. So order of operations, I have to do what's in parentheses first. So that's going to give me 3 times whatever's in parentheses, which is 7, but that 7 is still going to need to be squared. Order of operations, E comes next. E stands for exponents, so that means I have to do the 7 squared next, which means I'm going to be taking 3 times 49. And when I take 3 times 49, I get 147. going to look at a story problem in which order of operations might be helpful. So we have the question, or we have the problem. You buy a pattern and enough material to make 2 pillows. The pattern costs $5. Each pillow requires $3.95 worth of fabric and a button that costs 75 cents. Find the total cost. Well, first of all, when I think about this, I know that because I'm going to the store and I'm buying this stuff, these costs are going to add up. So my cost is going to include the cost of the pattern, plus I can either do, I know I'm buying 2 pillows, so I know that I'm going to be taking 2 times whatever the cost of a pillow is. So the cost of pillow. Well, it goes on to say that a pillow is going to cost $3.95 and a button, so plus the 75 cents for a button. So I know that I'm going to I need 2 of those because this is the cost of 1 pillow, and I'm going to need 2 of those. So I'm going to have this math, and then to that I'm going to add the cost of my pattern, which was $5. So this is going to give me the cost of my making 2 pillows. How much the pattern cost? $5. And then 2 times the cost of 1 pillow. 1 pillow costs $3.95 plus a button. So using order of operations, I can just keep that 5 plus, and now I need to figure out how much this is that's in the parentheses. Well, $3.95 plus 75 cents is going to give me 2 times $4.70. Again, order of operations, I'm going to have to do my multiplication first. So I'm going to keep the 5 plus, and I'm going to take 2 times $4.70, which is going to give me $9.40. So adding the $5 to the $9.40, my total cost is going to be $14.40.